Well, good morning, and thank you for the really kind introduction. It's really fun to be back in Napa and to see a large number of really familiar faces from my time at Davis, so it's great to be here. Thank you. I also want to take this opportunity to say thank you to Vintage Report for inviting me to speak with you today on the topic of vineyard uniformity, specifically grapevine shoot development as a function of arm positioning. As I was introduced, I am Dr. Jean Dodson Peterson. I've been at Cal Poly for about 2.5 years now. My teaching efforts are generally in the realm of basic and advanced viticulture. Before that, I actually spent 10 years at UC Davis in the viticulture and enology department and in the horticulture and agronomy graduate group. So I'm very excited to be here today. Before I jump right into the talk, I want to take just a moment and recognize the funding and assistance I've had on this project. I'm really grateful to the California State University Agricultural Research Institute grant. They've provided really generous support for this project. I'm also appreciative to Dr. Andy Walker, who has, even after I left Davis, continued to be a wonderful mentor and guidance. And then Oakville Station Advisory Faculty Committee for allowing me to do this work right here in Napa Valley, and the station personnel. As with any project, we also need a huge number of undergraduates to really help us collect all this data successfully and get it all in, and so thankful to them. And then finally, I had 2 graduate students that are helping me on this project, Brooke Robertson and Dylan Ellis, and I'm thankful to both of them as well. I think we're stuck here. I think it's frozen. Oh, there we go. Oh, there it goes. It's ready. All right, slow computer, that's fine. So the concept of variability is one that relates really to any discrepancy in our vineyard or non-uniformity issue we may have, right? In vit specifically, or any agricultural crop that perhaps uniformity is an issue, it can be season dependent, it can be compounded with environmental factors. I think the biggest issue we have right now is thinking about environmental changes. We have less and less irrigation available to us, and what viticulture looks like is changing. The techniques that we're using need to change along with those environmental pressures. And so as we move away from a system where irrigation is really almost a non-issue and we don't have to think about it, it's coming to the forefront. We have to think about what viticulture is going to look like next year, 5 years from now, 10 years from now. How do we change our system to maintain quality and vine health, but yet be responsible when it comes to water applications and potentially get to the point where we're really not using water applications for anything other than perhaps even establishment. So from a vit perspective, variability is incredibly important, especially when it comes to fruit quality. You know, today it's not my intention to negate or discount the role that, say, cluster thinning, water management, or even cultivar selection really has on the success of a vineyard. Those things are incredibly important and help lay the foundation for success. But variability is something that we face every year, right? We plant our vineyard once and we make that cultivar selection. We plant our vineyard once and we make our training and trellising decision one time in general, right? Variability is an issue that comes up every year, or how we manage and adjust for those environmental challenges and factors that we're faced with. So, you know, here on the screens are a couple of the issues we can face when we have major variability in our vineyard in terms of how our vine is developing, progressing, and growing. When we have variability or non-uniformity issues with respect to, say, shoot development, we tend to see issues with crop estimates, how well we can get decent and uniform spray coverage, the consistency in our fruit quality at the end of the season, and the actual timing of maturity. These issues certainly have an impact on fruit quality and the subsequent wine quality we're getting at the end of every year. Uh-oh, it's doing it again, people. It's just frozen. Oh, there we go. It's just slow. I think we're all familiar with field scale variability, and you know, whether it's in reference to, say, soil texture or topography or even microclimate within our particular vineyard or blocks. We accept a certain amount, right? We're aware that variability in a vineyard block is just something that's inherent with respect to any sort of agricultural-based crop. The larger the block, generally the more variability we're going to see over this bigger landscape. When these forms of variability are serious enough, growers are sometimes forced to say harvest in multiple harvest pass, or maybe leaf thin or cluster thin in multiple passes, and it becomes kind of an economic issue in addition to just being a quality-based issue. I want to pause here and just recognize for a second that variability itself isn't necessarily a bad thing, right? We like a certain amount of variability in our vineyard or with respect to how our crop is developing because we like the complexity to a certain extent that comes out in how our wines are developing. So it contributes to a lot of interesting characteristics. Non-uniformity is really an issue when it's involving or impacting our economic viability or our ability to manage our vineyard in kind of a cohesive and time-effective way. When we think of delay, it's generally in context to or with respect to the key phenological events that we sort of focus on when we think about. So bloom, set, veraison, bud break at the very beginning of the year. Weaker positions along the cordon are generally easy for us to identify. We can sit in the truck, we can take a peek down the row, and we can see stunted growth. We can see maybe a shoot that the clusters have shriveled because our shoot isn't pulling enough or partitioning enough carbohydrates to that location. These delays, these discrepancies tend to translate to issues compounding year after year after year. The purpose of the research that people asked me to speak on today was to kind of document which arm positions traditionally are struggling with this issue and to really determine if we can, within a single season or a single winter season of pruning, address these issues and try and normalize shoot development along the length of the cordon. So this isn't necessarily a problem that you're going to have at the very beginning of your vineyard life. Maybe it is. Some people just struggle with it right at the beginning when they're training, but it's something that hopefully you realize and you can catch right away and take some steps to sort of correct for early rather than, say, having to retrain new cordons and lose a year, or allow those weaker positions to, say, die off and then be stuck with a situation where you need to bunny ear and then you get all that crop being sort of compacted in a particular location, right? We're trying to catch these problems on a year-to-year basis so that you are continuously addressing and increasing quality as quickly as you can. So hopefully at the end of this project, we can get to the point where we can make some pretty specific recommendations on how much you should be adjusting, say, shoot per meter in such a way to help you address these issues, given whatever your specific vineyard environment is. So this study was conducted in 16-year-old Cabernet Sauvignon at the UC Davis Oakville Station, so just right up the road here. It was on a traditional VSP system, and the vines were on 1.8 by 2.5 meter vine by row spacing. Bilateral cordons about a meter off the vineyard floor. Row orientation was in the north-south direction, and the treatments we put into place were two sort of very ends of the spectrum when it comes to shoots per meters that we left. So either 5.5 or 11.1 shoots per meter were left. That translates to, in this scenario, 10 or 20 buds respectively left on the vine for actual primary shoot development. We also wanted to make sure we were accounting for and thinking about light penetration into the canopy. So we used an Acupar LP80 to measure photosynthetic active radiation into the fruiting zone, and that's where we get that third treatment. We wanted to take that denser canopy and really leaf thin to the point that we were getting same light penetration as our 5.5 shoots per meter, so that we could say, okay, light wasn't the issue here directly. It was how many sinks did we actually have. So we have a total of 3 treatments here. In an effort to really document what was happening with variability from a vegetative standpoint, we sort of cast a large net initially. And these were the factors that we found to be really interesting or that we wanted to focus on from a vine point of view, all right? So pruning weight, cluster weight, shoot length, and then spur diameter. We did collect berry samples, and we are analyzing composition of those right now. We just haven't quite finished digging through all that data, so we do want to, make you aware that we are sort of taking it through the entire process. I just don't have that for you today. So what we found were some general trends in that end cordon positions are, of course, generally much stronger or more developmentally advanced than the positions originating from mid or even head cordon arm positions. We also found that fewer shoots per meter really did get us to the point where we were able in one season of pruning to really bring it back in and normalize growth or homogenize growth down the length of the entire cordon. So we were basically eliminating variability. So being cognizant of and adjusting for shoots per meter was incredibly helpful in sort of addressing this issue. So let's take a look at some data really quick. So here we have pruning weight specifically. Our y-axis is pruning weight in kilograms. Our x-axis is our 3 different treatments shown by position. So you have end, middle, and head positions where fruiting shoots are originating from. You can see in our 11.1 shoots per meter treatments, both the leaf thinned, designated in the middle there by LT, and the one where we left the full normal canopy, we had some incredible variation. We have much stronger positions at the end, a lot more pruning weight at the end of the season there. When we were able to adjust bud number and bring it down, we basically eliminated any statistical variation, which is excellent. This is one of the few times where we can stand here and be very excited about no statistical differences. That's exactly what we want to see. We want to get that variation out of the picture. One season of really good pruning decisions can kind of get you back on track, right? Think of this as a 2-year process. Our dormant buds, all of the cluster primordia for next year are in there in the previous year at bloom, right? So this is a 2-year process. So you're not just impacting and sort of fixing a short-term problem. You're having a really positive effect on what's going to happen next year, assuming that you continue to be cognizant of what you're seeing. Now, with shoot length, we saw the exact same trend, which is fantastic. We were able to sort of not just eliminate variability, as you see here, but we were actually able to sort of increase individual shoot vigor or growth over the course of the season to a point where there was absolutely no differences, and they were all stronger positions that you can see here. We were a little surprised to see that there wasn't a huge amount of variation as a function of spur diameter. So spur diameter as an indicator about whether something's going to be caught up or delayed actually really wasn't that important. We were really thinking initially that we were going to see these little tiny positions always being the weaker positions, and that just wasn't quite true. All right, there really was not the huge pull apart or trends we saw with respect to position. Now, the one thing I want to point out here is I'm saying, okay, in positions are always more developmentally advanced here. We need to think about that. But a lot of it has to do with how you're initially laying cordons out on the wire. Are you wrapping them? Are you just tying them down, right? So that initial sort of training step is playing a big role here. So you might be saying, you know, in my vineyard, I'm actually seeing a huge amount of variation right at the head of the vine, right? It doesn't necessarily matter. Most sites are going to be very consistent in wherever those weaker positions tend to be. Maybe yours are at the head, maybe they're in the middle. But the point here is we can really prune to adjust these issues. So granted that this analysis is very much in the early stages and we haven't got to the point where we can dig through what's going on with the berry composition stuff, but I want you to realize here that these are very simple techniques that you can actually in real time implement in your management decisions and really reduce your ability to have to send that labor crew twice to leaf thin at 2 different times, or send your crew through twice to cluster thin, or send it through twice to make 2 different harvest passes. Adjusting shoot per meter is just so much easier, right? So just think of it as, you know, I need to walk my vineyard block, not just during the season, but I also want to maybe flag those positions that tend to be weaker so you can easily adjust for that. And of course, like I said, overall vine health. As we move to a more droughted system, and we change the way we think about how we interact with the environment and what our responsibility is to be conscientious viticulturists, moving towards a system where we recognize that we need to be more in tune with vine health and the little decisions that we can make to sort of maintain health over a long period of time. These are things that we can do to sort of rein that in and think about it. And we're going to see more stressed systems as we continue to have less and less rain over time. I know it doesn't seem like that right now with all the rain we just got, but it will get to the point where we're going to see more and more stress sort of compounding. So, like I said, berry composition is still sort of in the looks. Looking to the future, there's very likely a cultivar to cultivar factor going on here, where it's not just that Cab Sauv and what we see in Cab Sauv is going to be uniform for everything. We very well may see differences, whether it's Chardonnay or Sauvignon Blanc or Sangiovese or whatever it might be, right? We have a genetic component here. And then I wouldn't be sort of staying true to myself if I didn't take a moment and say rootstock, right? Rootstock is generally where my interest in research sort of lies, and we know rootstocks drive a lot of vigor induction with our scions and everything else. And we will likely need to explore how our vine responds to different pruning treatments with respect to sort of normalizing behavior dependent on what rootstock we're on. Is it Vitis berlandieri, Vitis riparia? Is it Rupestris riparia? What's in the background and what kind of induction of vigor are we getting? Do we see plasticity and how our vine scions are responding to this different type of treatment? And so with that, I'm getting the wave that it's the end of my turn. So if there are a few minutes for questions or no? Okay.
Maybe we can put the slide off if some questions have been asked, no? Okay, Doc? Can I have the mic, please? Thank you.
And the 5 shoots per meter, did you see a lot more lateral growth?
We actually didn't see a lot more lateral growth. We went through and kind of scored the number or the density, so we were sending the light bar through on a rather regular basis, and we actually didn't see any uptick. I do think that's going to be heavily tied to scion cultivar. I mean, obviously, if we were talking, say, Barbera, that has a tendency to push a lot more laterals, it may be more likely that we would see more of an issue with that. But in cab, that didn't seem to be an issue for us. Great question. Excellent. Thank you guys very much.
Thank you, Jim. And good drive.